All right. Good morning, good afternoon, good evening, wherever you are in the world. We are so glad to have you for this roundtable on designing for IoT today, experiences and lesson from design houses. Welcome to all our attendees. We're so glad to have you. It's really a pleasure. We are so glad that you're attending the first virtual ST Developers Conference. And so just to start very quickly on a few things, I'm getting a little echo, so I'm going to make sure that things get sorted out. So very quickly, first of all, attendees are invited to participate. So if you have questions, we would love to get them from you. You have a Q&A feature in Zoom, so please feel free to use that, and we will try during our discussions to get your questions there. We also ask that if you would like to specify the gender pronoun that you identify with, please do so. We would love to be as respectful and inclusive as possible. We would like to remind you, that the event is live streamed. So there will be there is currently a YouTube live at the moment. And so if you would like to ask questions anonymously, you can do so. If also you would like to answer polls, because we will have some polls during the discussions. If you would like to answer polls anonymously, you can also do so. So thank you very much for that. All right, let's just jump right into the discussion because we have a fascinating conversation for you today. On designing for IoT today, and we have two great design houses with us. So we have Siana and Sylvain Bernard, who will be representing Siana on the right corner. On the left corner, we have Jake Sprouse for Synapse, but I do not anticipate a boxing match. And we have Edoardo Gallizio from STMicroelectronics, who I'm sure will not be acting as a referee, but will bring the discussion together. And so to start, let's address the elephant in the room, because we have this global pandemic, and this pandemic is definitely changing the way we do things. And I love this quote from Philip Seymour Hoffman, the actor and director, who said that creating something is all about problem solving. And so today, what I would love to ask is basically, how do we solve problems as engineers? Because right now we have two very competing constraints. On one end, developing for IoT demands time, prototyping, roadmaps that can take quite a long time. But the global pandemic has brought on new challenges, completely new challenges. And so now with all this, the question is, how do we reconcile these 2 points? So first, let's go to Sylvain Bernard from Siana. Now, let me introduce you to Sylvain. Sylvain is the owner and principal architect of Siana. He's an electrical engineer by training, and he's been involved in the embedded industry since the 90s, working for small shops, startups, or even very large companies. His professional experience is interesting, and I know we're going to benefit a lot from it, because he has a lot of experience in a wide variety of settings, from low-level embedded systems to human-machine interfaces, full stack IoT. He works on critical projects, on R&D. He has a lot of experience in different aspects of the operations at Siana, and in the blog post. So if you go to the ST blog, blog.st.com, we published a paper on Siana, where he talks about his experience transitioning or working, with the STM32MP1. So he has a lot of experience and professional advice. However, I must say that the recipe to his gorgeous long hair will remain secret. So Sylvain, can you tell us a little bit about the sometimes contradicting aspects of working as an engineer with this global pandemic?
Sure. Well, thanks, David. And hi, everyone. So yes, definitely the pandemic has been a challenge, though I have to say it's been a very interesting last 6 months The first couple of months were definitely testing ground. But I have to say, we are used as a design house to working remotely. So, the main way we interact with customers is remotely. So for us, it's not much of a change. But what we've seen is a lot of our customers, whether they are really small startups or very large company, they've adapted really well. So, I would say now, almost everyone we're working with is pretty much at that point. They've changed the way they work. They're used to working remote. Their managers and executive, they're totally up to the whole remoting and working from home and not being in the same room. So for us, it's been actually positive in the sense that, it's always been kind of like over the last 10 years, something that we have to prove our customers that it is possible to work remotely, and it is actually nothing, it's not diminishing our potential. I think now most companies worldwide have experienced it firsthand. And it's been actually a leveling ground for us. It's actually really good. And I'm hopeful that it's going to keep on going. I think it's just setting new standards on how we work. So we haven't seen it affecting now that, a lot of people are used to it. We're not seeing it affecting really much how products are being developed and how we're doing development. To us, it's just been a period of adaptation. And then, we're just moving on at that point.
Great. Thank you very much. I think this aspect of working remotely definitely did what was maybe a positive that came out of this, terrible situation, in the sense that it did change expectations. So thank you very much for that. That was a great answer. All right, now let's ask the same question to Jake Sprouse. Now, Jake is the head of technology at Synapse. He joined Synapse in 2007 after completing a degree in robotics in Carnegie Mellon University, where he worked on implementing computer vision systems for autonomous vehicles, and he studied machine learning and embedded programming before it was cool. So he's one of, a pioneer before he became buzzwords in the media. Jake has a unique take on this conversation because he began as an embedded software engineer, and now with a lot of expertise, in C, C++, and now he's also working on software architecture, sensor data processing algorithms, and his role as the head of technology at Synapse also means that he's investing a lot of himself into new engineering and science disciplines. And in fact, I also invite our attendees to check out the blog post that we had that we just published on Synapse, because there is one aspect that Jake emphasized a lot was vision for his customers. I don't know if it's because he started on vision and he has a long vision for his career that he emphasizes the word vision. Now, I've said the word vision too much, but Jake, can you please tell us how do you reconcile, you and the people who work with you at Synapse, sometimes what seemingly contradicting aspects, that are brought on by the pandemic?
Yeah, absolutely. And thanks for having me today. I think that having different perspectives is great. And so Silva, with his long hair, I'm happy to bring the non-existent haircut perspective to the conversation. So, so for us, it has been a bit disruptive, and I think that some of our customers are seeing similar disruption in their the way they do their jobs. A lot of what we do is at a desk, and it works very well to go remotely. But a lot of what you do is, if we're using buzzwords, we call it agile hardware development, and it generally means fast prototyping cycles and learning quickly and failing fast and so on. And for that, you generally need co-located teams that are working together in a lab. So we've had to rely a lot on, social distancing techniques in our labs, and a lot of couriering of prototypes around the city and up and down the West Coast in order to proceed as usual. But in terms of product development cycles, consumer product development, we're really used to these fast product development cycles. We're very familiar with the customer who comes to us in March and wants to have products on the shelves by Black Friday in time for the holiday season. So that's nothing's changed much for us there. We do have some companies that we've seen in medical technology that are having to adapt very quickly to rapid development cycles where they may have been used to, 3 years, 5 years, even 10-year product development cycles with the regulatory environment. But that has been fairly well upended for a lot of the medical technology companies in this environment. And we've seen a little bit of the consumer health companies that are really trying to get a product out faster than usual because there is a high demand for products that help people stay healthy and well at home. But for the most part, it's normal product development cycles on the engineering side. Probably the biggest concern we see is some of the impact on supply chains. So we're advocating that it's more important than ever to have a team working with you that understands design for manufacturer and manufacturing operations and really just how to work with CMs. Just because the pandemic has disrupted a lot, and you need to design your product in a way that can be adaptable to potential, flexibility in the supply chain and so on. And then even with the pandemic aside, the last few years have seen the picture for global manufacturing and supply, raw materials and so on become much more volatile. Trade wars and such sort of means that it can be very hard to have confidence in your bill of materials targets and the price point that you're trying to hit for a product. I don't have great advice there. There's not a whole lot to do except get a little bit defensive with your product development strategy and your pricing strategy, and vote for stability in your next election that's coming up. So.
All right. Thank you for that. I promise our attendees we will not hold a poll for whether you're voting for Biden or Trump. We're going to leave that out of this conference, but we will have a poll a little bit later on. But for now, thank you, Jake, for this answer, because I think you highlighted two great points, which are, well, many points, but two that I picked up really was this need to be familiar with your customers, familiar with what they're going through. Understand that, yes, some of them, you're talking about the medical field, you were talking about consumer health, did get really shuffled a little with everything that's happening. But if you are really attuned to what they're doing, then you're able to meet their needs and answer their request. And so let me ask now the same question to Edoardo Gallizio. Now, Edoardo is a senior product marketing manager at STMicroelectronics for the America region. He handles MEMS and sensor products across North America and South America. He addresses, among many other things, personal electronics, industrial, and the automotive markets. Now, Edoardo has a very interesting history. He traveled a lot for ST, and he relocated to the US in 2013. He was a voting member of the IEEE committee that defined the 802.11n specifications for MIMO Wi-Fi. So that's fascinating. He is an electric engineer by trade. He authored also several patents on digital signal processing and wireless communication. And one thing you may not know about him is that he loves gardening and cooking. So please be aware, if he sends you a pasta emoji, it's completely organic. Eduardo, welcome. How did ST balance those two constraints between the delays and the time it takes to bring those technologies, and at the same time, the rush and everything that happened with the global pandemic?
Yeah, that's a very good question. And I think we tried really our best in the past, 6 to 9 months now, depending on the country. ST is a global company with, operations and teams in many countries. So definitely we have been, let me say, affected by this pandemic. I would say at the end, I think we might be affected in a positive way. I think we've been adapted fast. We definitely embrace the new remote working and smart working as is defined in Europe specifically. Definitely was not easy. We had to adjust quickly, sometimes even bringing, lab equipment at home for our FAE in order to continue supporting customers during these past month. I think we did really outstanding support from all the team in America and worldwide. ST has been also, adopting and adapting to the to the regulations that every country was putting in place in the past month. But I want to say that definitely we were, lucky, brave, or wise enough that we didn't have to stop any of our manufacturing plant. And this was really a big asset. Okay, so I think many of our customers recognize this effort in keeping the supply chain and continuing also developing new products despite all these, let me say, mess that is going around. Now, on the other side, I picked also a couple of very important points from Sylvain and Jake that I think is worth to underline, because I think we have realized more than ever in the past several months the importance to really establish or reinforce a strategic partnership. And I personally believe, and I have been working with, Synapse, for instance, since, the day 2 that I moved here in US. So I know, and I have quite a bit of history with Siana recently, also on several maybe audio platforms. So we as ST clearly recognize the strategic importance of partners such as design houses that can really help to fill the gap from a semiconductor, let me say, giant or big corporation like ST to the vast number of customers that we can address in these new, let me say, IoT, either it's industrial IoT, consumer IoT, or medical IoT. But in order to reach those customers, we really need help from partners, and we need to rely on those relationships, specifically in these past months where having in mind already a work flow or having in mind a way of operation was a big plus. So again, it's difficult to address all these points, but I think those are really, really important. So partnership, vision, and continuity of supply chain from a semiconductor standpoint.
Great. I think this is a great answer, because it does highlight like most of the major moving parts in an engineering team, or what they're going to face in terms of vision, in terms of supply chain, and the crucial importance of partnerships. And I think that's a common thread that we saw. Now we're going to ask our audience to answer a poll, and it may be a bit of a surprising poll, but there is definitely a question there. We've seen a lot of engineers come up, and whether it's medical engineering, whether it's social engineering, or in our case, obviously a lot of electrical and electronics engineering, do you think that engineers and tech companies have a duty to find solutions during this global pandemic? Readers of the ST blog will be familiar with some cases that we talked about, with a wearable that is helping with social distancing and physical and contact tracing. Sorry, ST recently published its physical distancing SDK. So that was an important aspect there. And so do you think right now a lot of the answers are yes? And it is an interesting answer. And let me ask you then, Jake, let's start with you. Do you think tech companies have a duty? And at the same time, we understand that the global pandemic is definitely a world crisis. But if we're trying to achieve a positive note, do you have some success stories that you can talk about that came about during the recent months?
Yeah, absolutely. And I think the general answer is my personal take is that, and not to influence the poll results too much, but no, tech companies do not inherently have a duty to solve the pandemic. The responsibility for helping with this pandemic really relies on our ability to function as societies and take collective action and listen to science and so on, and turn that into public policy. Technology will play a role in solutions to pandemic, like the social distancing wearable that you mentioned. And I do think that tech companies absolutely have a moral obligation to stand up and help when they're called upon to do so. And we've been lucky in a couple of small ways, and one big one. We had a project that was led by the government of the UK, where they very much wanted to make sure that they had a supply of ventilators for potential spikes in COVID cases, and they wanted to make sure that those ventilators could be built using a domestic supply chain. So we were commissioned to design that for them, and we spent 6 weeks, 40,000 person hours of work to build a fully tested and regulatory approved ventilator system in just a month and a half. And so that was a huge success story for us. Certainly not easy, and certainly not something that any tech company can really do independently. And as a matter of fact, a lot of efforts that happen independently without being coordinated with the science and epidemiologists and so on can actually be more harmful than helpful. So I really do think it's important to help, but do it in the context of governmental efforts and science and so on.
Right. Thank you very much for that answer. Sylvain, what about you? How do you see this this problem?
Yeah. I mean, no, I agree. This is, it's not the responsibility of technology company per se. However, I mean, technology is clearly one of the largest solutions to managing that global pandemic at scale, right? I mean, we have to be able to adapt the way we use technology, or actually develop new technology to solve that gigantic issue. And I've seen some of the companies with whom we're working that they've been thinking outside of the box and trying to figure out how could they be using the technology that was proposed for totally different context in that pandemic. And we've had a couple instances where we were involved with that type of outside the box thinking. I can't talk about it, obviously, but there has been some instances where, coming from the engineering team rather than from the market, being able to come up with a variant on some of their product to be able to solve a specific case that would contribute to the pandemic, solving the pandemic. So, we've seen some of that, and, I'm seeing more and more of that now. People are starting to come up with a new way to use existing technologies, repurpose some of the existing technology to do that. So, I'm hopeful that we'll see more and more of that over the next few years, actually.
Right. Thank you. I think those are great answers. And this could be a much larger debate. We don't really have time, maybe for another roundtable, because I think there is a discussion here around both the word duty and the word solution. And so both of you, Jake and Sylvain, did emphasize naturally the fact that you're working towards solutions, even if they're not solutions that will solve the pandemic itself. Maybe as engineers, we're driven by this need to find solutions to common problem, or as we mentioned, for instance, social distancing and contact tracing. And so this isn't part of that drive to find solutions also a duty. That's the attendees are answering yes, which is fascinating, but I think that's a much bigger conversation. But I thank you very much, because I think also it highlights the fact that engineering, the word engineering, is much bigger than what we in our industry are used to. And actually that will help me move to another the second question that I wanted to ask you. So the French author Marcel Pagnol said something that fascinates me. He said, you ought to watch out for engineers because they start with a sewing machine and they end up with the atomic bomb. And so I love this quote, and some may find it, negative, but I find it extremely positive because it shows the breadth and the scope of engineering. And so when we talked about the discussion in the context of the global pandemic, engineering was, is such a big word with so many notions that it encompasses. But my question here for this roundtable is about the strategies. Already, both Jake and Sylvain, you highlighted maybe some of the differences or some of the subtleties between each of your design houses. So let me ask Edoardo first of all, because that poses an interesting question for ST, who works with a lot of design houses. Obviously, how do you tailor your approach to each design house? What can you share behind the scene that can help maybe the CEO of a startup or the engineer in a big team from a big company address some of the subtleties of working with a manufacturer?
Yeah, that's an interesting question because you're right. So ST has multiple partners, and I think on st.com/partners, you can find now a long list of partners, and among them, there are several design houses. But I can tell you that not everybody has the kind of expertise or capabilities that some of the really strategic design houses, and today really I think we invited, among, I believe, the best design houses that I believe we have in North America, because we recognize that their capability to tackle not a trivial problem, let me say, either in an innovative way or with some also proprietary IPs and way to address with ST technology, and sometimes also with complementing technology, because again, I'm proud, I believe, to work for the best sensor company in the world, and we have a lot of semiconductor components, but we need to be humble sometimes. There are also complementing technology that ST doesn't have. Still, we need these capabilities and expertise to tackle those problems. And we were talking about pandemic, but I believe there are even bigger problems that as humankind we are facing. And in discussing with Siana and Synapse, we see that there are mega trend or macro trend that are happening in our industry, right? So let me say the touchless trend that definitely the pandemic has accelerated. So the needs for more voice type of activated application will stay. Not even when the pandemic will be over with a vaccine, etc. This will become, definitely a more present and needs in the society. On the other side, like the agri-tech, okay, is a sector that sometimes we forget. But there, you were mentioning that I love gardening. Yes, I love also wines and vineyards. My family in north of Italy, we produce wine since generations. So I know that technology can actually help to produce more food, or to produce better the food, or to avoid using pesticides and so on. So for those specific, let me say, not trivial issues, that's where we need the specific capabilities and expertise in design house. And we try also to tailor our not only relationship, but how we engage sometimes with, early stage technologies, okay, with the strategic partners. Because one story is, okay, we have a catalog product on ST website, but then as, semiconductor industry, we develop and we are cooking a lot of other technologies that maybe are still not on the website, but we need to work with strategic partners and design house to validate and to bring those technologies into the market to really solve real issues.
Okay, but Edoardo, let me push you a little bit further, and let me do it with a question from Jen. She just submitted a question, a really interesting question, because you mentioned that there are bigger problems than the pandemic, or there are a lot, not necessarily in terms of competition. We're not trying to play the Olympics, but the point of saying there are macro issues, and right now, we're talking a lot about the pandemic for obvious reasons, but there are other macro issues to deal with. And she's asking, in your opinion, what is the biggest problem to be solved by engineers right now? And so I'll ask you this, and then I'll ask Jake and Sylvain their opinion. But first, to answer Jen's question, what is the biggest problem to be answered by engineers right now, according to you?
I can bring, something that pops up in my mind is, how we can make sure that, a lot of food don't get wasted every year. Okay, so again, there are already asset tracking solutions, there are already, sensing technology or refrigeration technology, but I believe there are, and there might be innovative way to maybe preserve food that is already available. Another big trend that I see is transportation. Okay, the need is, I think, as old as humans. Okay, now I think there are technologies that are already available, but maybe are still not available at scale for everybody in order to have a more efficient or a less impacting, on the, let's say, climate or on the pollution of the places where we live. So those to me are two big, let me say, problems that from an engineering and an electronic engineering standpoint, we can help to solve.
Okay, let me ask that question to Jake. Jake, what do you think is the biggest problem to be solved by engineers right now? if you had a magic wand. And Jake, just to remind you, you're muted.
Yeah, it's a very interesting question, and I think that thinking about what are the biggest problems that engineers can contribute to is a different question from thinking about what problems that engineers can have the most impact on, and technology will play the biggest role in solving. I do think that climate change is huge, and I think that the given the right context and the right support from society at large, that engineering can play a huge role in that, not just in directly combating climate change, but also in what Edoardo was mentioning, helping with the agriculture and food supply, making sure that waste goes down, transportation, engineering, and so on is a big one. Moving goods and people around less. Things like well, there's a fantastic book called Breakdown that gives the top 50 problems in climate change, and the solutions to which will be most impactful in order. And it's a fantastic book to read there. But I would like to give an honorable mention to social networking. I think that social networking is having a huge impact on our public discourse and our ability to work together collectively as societies. And I think that there are mechanisms that can be put into place to make the public square, if you will, a much more useful place for constructive discourse. I think that warrants a lot of attention from engineers. It can have a huge positive impact if we get that problem right.
Great, thank you. What about you, Sylvain? What do you think is the biggest problem to be solved by engineers right now? Do you have a different take than Jake or Edoardo?
Not so much different. I totally agree. Everything that's been brought up, food production, pollution. All of that clearly are some of the gigantic, the challenges of the new generation. Every generation has challenges. This definitely by far everything that has to do with the environment in general. Now for me, to bring it down back to engineering per se, some of the things that I'm seeing is, as a big problem, it's product and electronic obsolescence. We are producing more and more of these devices. They end up on landfills. They end up all around the world. We are designing for a very short life cycle. I think there is something that we need to do here as engineers to solve that problem, because this is rippling down at so many different levels. Now, in terms of engineering, the challenges these days versus, let's say, 20 years ago, engineering is very complex now. If you're designing a product, especially an IoT product brings in so many layers. You've got to have the communication stack. You have to have the RTOS, the user interface, the speech engine, the security layer, the provisioning layer. So you're bringing all of this stuff on the lap of the engineers, and they've got to solve it, and they've got to solve it in very short time to market. Shorter and shorter time to market, and all of this leads to what I was bringing earlier. This electronic obsolescence. We're taking shortcuts on almost every aspects of the design cycle, and I think we as engineers have to do a little better than that. And I don't know what that is. I'm just seeing it as the complexity is increasing dramatically. We are having more and more now so-called AI that are coming into the embedded world. It's going to put even more and more pressure on the engineering teams, and that's, I think, a huge challenge that as a professional we'll have to tackle and solve very soon.
Thank you. Those are great answers. I am sure Edoardo want to highlight also ST's commitment to longevity, talking about obsolescence and the fact that we support many of devices for 10 years or so. We have extremely long commitment.
20 years.
or sometimes even 20 years. Yes, that's right.
Yes.
But let's move the discussion to another point regarding this. So as we are working on solutions for the environment, climate change, pollution, rapid obsolescence, let me ask first of all the attendees. I would love to ask, so the second poll question, which is when designing for the Internet of Things, what is the first thing you look for when considering a specific part number? So the question is on your screen, and we're going to ask, so let me ask first, Jake, let's ask first the design houses. Especially, what do you look for first? What does your team look for first? And what advice would you give in that regard to startups who are approaching you? So what do you think they should be looking out for in terms of either specifications, development board, cost, longevity, familiarity with devices, or something else? What would be your take on this? Jake, you're muted, by the way, just to let you know.
There we go. Yeah, thanks. I think that Sylvain and I would agree that from a design house perspective, it's really all about the customer's requirements. And so, we don't come with our priorities for technology selection presupposed. We really try to step back and listen to the customers and understand what they're trying to get done, and work with them to understand what really the priority should be. A lot of customers, it's a time to market issue, and so the availability of prototyping kits and some of the solutions that ST provides with their Nucleo and so on, prototyping can really be a huge advantage, and that might be the biggest priority in selecting a part. Sometimes it's it's the COGS target is the most important thing, and we're going to look for the part that will reduce the bill of materials appropriately. Sometimes it's the user experience, and you're worried about the size and the industrial design of the product. You're worried about the power consumption, and so on and so forth. So really, it's about listening to the client and what they need. I will say that often a client will come and have cost constraints. They only have so much money to spend, and a partnership with ST can go a long way in that regard, because having this tight partnership with ST allows us to really have that working relationship pre-established. It reduces the NRE cost. We're already familiar with the parts. We don't make the mistakes that somebody just learning a part might make. And also, in exploring a solution space for a customer's needs, understanding ST's roadmap. We work with Edoardo and his team and other groups at ST to understand what will be coming from ST in a year or 2 years from now, and that actually might be the most important solution for a client's problem. And so knowing that off the bat can be a really big advantage for which technology we select for a customer.
Great, thank you very much for that. Listening to the client, understanding the roadmap. Sylvain, what about you? What would you look for first? Right now, the polls are, you have a very interesting, almost a tie between people first looking at spec sheet and the other group looking at development boards and tools. So what about you? How do you approach it, and what would be your advice to startups with this question?
Yeah, especially for IoT. So I fully agree with Jake. I mean, for us, from a design house perspective, it's all about what the customer wants and what their requirements are. Now, when it comes to IoT, it extends beyond just the device requirements. I mean, you need to understand the expertise that the customer is bringing in an IoT product. I mean, are they a hardware manufacturer? Are they knowledgeable about mobile app development, about cloud development, about being able to do DevOps for all those layers? I mean, that usually dramatically increases the complexity of an IoT. So, what we've been seeing is like, you have like pretty much two camps. You have people coming from the IT side more, the cloud side. They already have maybe mobile app experience and cloud stack experience, and they don't have embedded per se. So oftentimes you'll have the people playing with Raspberry Pi and Arduino and devices like that. And now they want to do the actual high production version of it. And then on the other side, you have the hardware makers. They are used to doing really low-cost devices or really highly optimized devices for production, and they may not know what it takes to just provision a device to secure it on, in the cloud, all the steps involved in that. So it really depends for us when we come in for an IoT device. This is about understanding who the customer is, what they're bringing on the table, and then understanding their requirements. What is the system? What does the system need to do really? From there, you're right. After that, this is about part selection. And for us, we're an ST shop. We are ST centric. Most of our development is around ST. So the very first thing that we'll do is bring in ST on the table, and start discussing, like the low-level details of what parts we're going to be using to solve those requirements.
Right. This is a great answer. Thank you. The need to understand the IoT complexities and expertise, which leads me, and I'm going to ask you first, Edoardo, but there is this great question from Professor William Kaiser, who just submitted it. He's a professor at UCLA, and for readers of the ST blog, he authored courses on IoT and a new one on motor control. And so he has this really pertinent question, which is that today we observe fundamental advances and new trends thanks to the prevalence, the omnipresence, I'm almost going to say, of IoT sensors that allow new artificial intelligence applications. So AI solutions are no longer limited by the type of sensors you can have. Not only we can put sensors everywhere, but now even sensors are getting smarter. We saw ST release the first sensor with the machine learning core. And so now, Professor Kaiser asks, are design houses, and I'm going to extend that question to ST, observing the arrival of new customers pursuing product development that merges IoT and AI? And let me ask you that question first, Edoardo, because ST has had since 2019 a heavy push on AI. We released STM32Cube AI, which allows you to convert a neural network into an optimized code for STM32 microcontrollers. We've invested heavily, as I mentioned, into sensors that have a machine learning core, and even released Unico GUI that helps developers really optimize their sensors really quickly. And so the question that I would have then is, basically what came first between the chicken and the egg, and what do we notice now after a few years? So was this an answer to market trends? Did we anticipate it and now we're seeing customers flock toward it? Or basically, how is ST handling this, and what do you see right now in your part of the world?
Yeah, let me try to reply in this way, and maybe I can be biased a little bit because I'm responsible for sensors, but understanding about systems and IoT, I think I have a good overview. So definitely what we see happening more and more is that people are now realizing that sensor nodes need to become more intelligent. Sensor node can become so low power that can be potentially on all the time. Now, in order to enable that from a semiconductor standpoint, we had and we are still pushing the boundaries, because again, low power consumption is important in many, many applications, right? Not only the wearable consumer, but now current consumption and power consumption is becoming extremely important in the industrial and even in the automotive, right? So the example of the electrical vehicle, to me, is very important, because before people were not thinking, right, automotive as low power domain. Actually, now it's becoming, because people are concerned that even when you turn on the HVAC system in an electrical vehicle, your range in terms of driving miles goes down potentially dramatically. So even sensors or any microcontroller that need to go into a vehicle, an electric vehicle, now need to be low power, okay, or lower power than it was even just a couple of years ago. Now, the merge or the combination of AI and IoT, to me, is not only happening, but is critical. And if we are able to address both needs, to me, can be a big part of success. Because if we are bringing, intelligence, again, a sensor node, let me repeat this analogy, to me, we can tackle 2 points. First of all, certain actions can happen locally. We don't need to bring all those data up to, let me say, the cloud, and then run complex algorithm, etc. Take a decision and then send back a command. Sometimes it's not possible, right? So let's assume that you have an emergency spill into a factory plant. Maybe you don't have any seconds or minutes to spend and to do all these complex processes. But there are even more easier tasks that having these AI and IoT capabilities, so Sylvain was describing before, all the complexity, right? Security, sensing, provisioning, etc. of an IoT device. So having those combined is definitely a challenge where I personally believe that alone as a semiconductor industry, we are not able to tackle all those problems. And that's where we need really partners and strategic partners like, key design houses that can really help to put the two things together in, by the way, not only in an effective way, but also in a scalable way, because definitely then we want not to produce golden sample, we want to produce millions of these sensor nodes, and also in a way that is addressing the needs of the customer. So I hope I addressed the question from Professor Kaiser, but that's my personal view and my take on this.
No, I think it is a really interesting take, and I think we benefit from the understanding that first there is this need to partner, and ST's looking to partner. We're not a silo, and sometimes it can feel, if you are in a small team or an engineer or contractor and you don't work in a big company, sometimes you feel that manufacturers are out of reach or that it can be hard. But actually, I think one of the messages that you have is we want to work with as many people as we can and as many partners as we can. And at the same time, understanding what is happening right now is critical. And this merger between sensors, IoT, and AI is critical. Let me ask now Sylvain, because Edoardo mentioned the need to work with partners like design houses to be able to scale those solutions. So let me ask Sylvain first. Are you, as a design house, observing the arrival of new customers that are pursuing, that are demanding this new marriage, so to speak, between IoT and AI?
Okay, so that's a huge question, right? And for me, right now, 2020, most of our customers, while they are aware, I mean, it's impossible to not be aware of all the AI, deep learning advances. It's all over the news, tech news, IoT and data analytics is just, it's a great match. I mean, you're collecting all this data, sitting somewhere on a data store in the cloud. You've got to do something with that.
Right.
For us, the vast majority of our customers are still using IoT principally for real-time monitoring and control, and some kind of analytics, historical analytics, but nothing yet at huge scale using AI or deep learning. I think, to go in the direction Edoardo was mentioning, to the whole, from a high-level system, getting everything working together is such already a challenge when you train security, provisioning, all these things. Now you do data analytics and AI deep learning, and now you have pretty much an entirely different business model, that you have to deal with. Now, what we are seeing now more, applying to embedded system is edge AI, edge deep learning, and especially you were mentioning the cube AI. That's something that we've been involved with from the beginning. To us, that's literally a game changer. being able to run a deep learning inference engine on the node locally to process data in real time. I mean, to us, that has opened up new application that we were not considering. Whether it's in sports wearable, being able to process inertial data to extract more information out of that, or even like some, abnormally, defect analysis, detection for some vibration devices. I mean, these are typical problem that, it's really hard to design an algorithm that would scale in production, that would be robust and stable in production when you're making, when you don't know all the context where those devices are going to be deployed. Deep learning brings it feasible on some of those challenges. And I think we're seeing, on our side, we're seeing more and more people asking about that. Definitely, it has enabled things like local speech processing in a much more efficient way, more performance. And so, we are mostly looking at that point on edge processing and edge deep learning at that point.
All right, thank you. And this, I really like your question because it ties in very well both with what Edoardo said and Professor Geiser's question. Because so Edoardo mentioned that we've been working on AI for a while now. He explained what was possible thanks to low power sensors, to the myriad of sensors, to emerging AI, and the fact that it's critical, but that we need to scale it. And now we hear you with Siana explain that, okay, a lot of your customers still use IoT for real-time application or control, but that you're starting to see, and so answering to Professor Kaiser's question, we're starting to see this move towards answering solutions. It is no longer AI for the sake of AI. We need it, as you mentioned, for solving complex problems with algorithms, for voice recognition. I also want to point out the MP Cam from Siana, which we talked about in the SD blog, that uses an STM32 MP1 and a camera module and a machine learning system to do image recognition and at a tremendously lower cost than what those solutions have previously needed. So there is this idea that we're now seeing this evolution from manufacturers have solutions like Cube AI to, okay, now the markets are starting to demand and use them because of solutions. What about you, Jake? How, what's the weather like at Synapse? Are you seeing new customers pursuing product developments that merge IoT and AI?
Yeah, absolutely. It's a fantastic question. I think from our perspective, we've had customers that are doing IoT-based AI type applications for a long time, and it's some of the things you would expect, like voice assistant and doing natural language processing in the cloud, given an IoT device, and camera-based solutions that upload images and then process them in the cloud and do very intelligent things. And that's been many years that we've done projects like that. The challenges in those projects tend to be designing a communications infrastructure, and as Professor Kaiser is mentioning, with better and better sensors, you wind up with the need for more and more bandwidth up to the cloud. And so really the challenges often wind up being, providing that communications infrastructure in interesting ways. So, I will just echo what Silva said, is that the recent trend has really been, going back to the resource constraints, and you wind up with newer customers that really want to do more real-time, low latency response applications that involve AI, or some customers simply don't want to pay the cost of the communication pipe and the cloud compute infrastructure. So they really are looking to that, what they call edge AI kind of solutions for doing this kind of stuff. And so I think there's a lot of interesting applications that wind up being a hybrid model with some AI on the edge and some AI on the cloud. that has a lot of great implications for, people's privacy. Instead of uploading, raw video with everybody's identifying information in it, you can do a lot of processing locally and then upload, meta information and do, data analytics on that instead. And we're also seeing some hybrid applications that really take the real-time parts of the system and make it local, put it at the edge, and do more data analytics stuff at the cloud. We recently worked on a project involving ST's machine learning accelerometers, and putting those accelerometers on power lines down in California to see if we can detect events that would cause a down power line and potentially cause a wildfire, just using the accelerometry data. And in those applications, you've essentially got, tens of milliseconds from event to the power line potentially sparking a fire. So you have to do that event detection very quickly. And then it's low latency to get that power shut off at that point. And then, all that data still goes up to the cloud, and they're able to do, data analytics to do things like predictive maintenance on power lines and understanding, where the power line infrastructure might be failing, and they need to send technicians out to fix things up before there's a wildfire. So, so that hybrid combination is something that we're seeing that's more and more interesting.
All right, thank you very much. Those are great answers, and I think they highlight some practical aspects. And I hope our attendees leave with this picture that there are definitely, it's no longer just a buzzword. There are definitely solutions that can be brought by bringing machine learning or artificial intelligence, to IoT. And we're living into this transition period, and I think Professor Kaiser's question reflects that really well. And it is important for engineers to jump onto that bandwagon, because that's how many will end up solving those issues. So as we are wrapping up now, our time is almost up. So let me ask you, let's start with you, Edoardo. In 2,000 years from now, I know it is impossible to see it, but in 2,000 years from now, when you finally retire, what do you think people will remember about ST, about your company?
Yeah, that's a difficult question, but yeah, I would love, as I mentioned just before, that some of these big problems that really, as humankind, we are facing, okay, so climate change that we talk about, or food production and food distribution, right, to make sure that everybody on Earth has enough food and has, enough resources. Those are major and complex problems that as a semiconductor industry, we will never solve together. We can only contribute. I would love in 2,000 years from now that if anybody will develop a unique and disruptive solution to tackle one or a portion of this problem, they will find ST name inside. That would be nice, okay, to me. So we will not only help, the PC or the mobile phones that are still helping our life, because I mean, let's not forget that mobile phones are very useful tools. Okay, PC are very useful learning tools, as well as vehicles that bring us around are very useful tools. But I would love that for these solutions that are still not here now, but maybe in the years to come, if some of the ST technology will enable that, I would love that.
All right, perfect. Thank you. Jake, let me ask you, 2,000 years from now, when archaeologists dig up IoT devices, and they read that it was designed by Synapse in the firmware, what do you hope they will remember from your company?
Well, I'll just say that I think they're going to remember us because they're going to find a device that's still working in that long from now, and realize that we built it. But no,
that's a great answer.
It goes back to Sylvain's point about the longevity of products, and that really is a goal, is to work on things that will have a long-lasting benefit. But on a more practical level, my role at Synapse is exploring a breadth of technologies, and I believe, and Synapse believes, that real innovation comes when you bring together technologies and science and disciplines from lots of different walks of life, and see what happens at the intersection. Like, there's always interesting advances that happen at the intersection of things that might not necessarily be related on the surface of things. And so, you know, my role is really exploring a big breadth of technology, and I want Synapse to be known as a place that brings together a lot of smart people and a lot of smart science and technology into, you know, some of the most groundbreaking products that have ever been invented. And I hope that our name is attached to some of those at the end of the day.
A very noble goal. Thank you very much. And I'm sure Sylvain would have loved to say about the product obsolescence, but you took it, Jake. So Sylvain, I'm going to push you to what other thing would you like Siana to be remembered for in 2,000 years from now, when you know, a piece of equipment, an IoT device is getting dug up, and we realize that you wrote the firmware for it.
Yes, I mean, so, you know, as a design house, you know, our goal is not to be remembered. We are here to help people design products, and you know, when it comes to IoT, it's all about longevity for me. So, you know, we are going to live in a world where you're going to have generations of devices that are providing the data for those AI. And you know, there's not going to be, we're not going to upgrade them all every 5 years or every 10 years. So you're going to have devices that keep on going. They're self-powering. They're sending a little bit of information every now and then to the giant cloud. And it'd be really cool. Maybe 1,000 years is a little stretch, but you know, it'd be cool to have some of those devices keep pinging the cloud, you know, regularly, and you know, it's running on Siana's code. So that would be good enough for me.
Pinging the cloud in 2,000 years is definitely a worthy goal. Thank you very much to all three of you. Thank you very much to Edoardo, to Sylvain, to Jake. That was truly a fascinating conversation, and I'm sure it helped a lot of our attendees during this ST Virtual Developers Conference get some perspective from your end of the industry. So again, thank you very much for this truly interesting and fascinating conversation. I want to thank each and every attendee for their time. Thank you very much to those who asked questions. I would also love to thank everyone behind the scene. Thank you to Giorgio, who managed the polls and managed the Q&A. Thank you also to Elizabeth for the live stream, to Allison and Pam for helping putting this virtual ST Developers Conference together. There is a tremendous hard work behind all this, and we're very grateful for their support. This roundtable would not have been possible without them. We also want to thank Daniele, who is the blog manager, and Gerard, who is the VP hovering over our activities. So we again thank you very much. We remind you that if you are interested in Synapse and Siana and their activities, you can go to blog.st.com to read more about them. We are also live streaming to YouTube, and so this video, this whole roundtable, will be on YouTube right away after we end this call. So if you would like to share it with friends or with colleagues, please check the ST YouTube channel or check the ST blog, where we will share it. We also remind you that this conversation will also be transmitted on the ST podcast. So again, thank you very much to Edoardo, Jake, Sylvain. Thank you to everyone. And well, have a good last day of the ST Virtual Developers Conference. And we're signing out. Thank you.
David. Thank you
Thank
all.
you, everyone.
Bye. Bye-bye.
Thanks.